So moving on to the graphs that are going to have multiple vertical asymptotes, like this one. All right. You'll notice the first thing when looking at this, you'll start looking at the table and you'll be like, holy cow, man. Why is that table... it's got so many spots and mine doesn't have so many spots. That means you may have to add some lines on yours. Okay? That should be the first hint on this graph that we're in for something special. All right. So, right now I want you to try to factor and reduce if you can. Okay? You get about 15 seconds to do that. Okay, so we reduce. Or excuse me, we factor. The bottom becomes?
X minus 1. X plus 1.
Good.
X minus 1.
Good. X plus 1, X minus 1. Okay? We reduce that. And can we cancel anything on the top?
No.
No. So in terms of holes, do we have any? No. None. All right. Now, in terms of our vertical asymptotes, do we have any? Yes. What will make our denominator 0? Yeah.
Plus or minus 1.
Plus minus 1. So x equals 1 and x equals negative 1. That means when I go over to my graph, I am going to have two asymptotes. I'm going to have one here at negative 1. And I'm going to have one here at positive 1. Which means I have the potential for having 3 branches. Yeah. Total what? That's awesome. Okay? Now, before we go any further into the table, how about the y asymptote? How many say 0? How many say it's at y equals 20? How many say y equals 5? Y equals 10? Y equals 1?
I think it's going to be y equals 20.
Y equals 0?
I think it's going to be y equals 0.
Y equals 0? Okay, well let's figure out why that is, okay? So, we're going to take this equation. I'm going to take that original we have. And this is a good place to add some stuff about horizontal asymptotes into your notes. Okay? So y equals 5 minus x. And I'm going to take the original x squared minus 1. All right? And we're going to talk about our horizontal asymptotes a bit, and then we'll come back to that problem. So, guys, give yourself a lot of room here because we're going to extend this into the next problem as well. Okay? So, this one right here, let's say I go ahead and rearrange this to be equal negative x plus 5 on top and x squared minus 1 on bottom. You guys with me? Yeah. Everyone's with me? Yeah? Okay. Now, let's pretend that we make x equal a really, really big number. Like a humongous number, right? Or a really small number, because that's when we get to our asymptote, right? When x is really big or really small, that's how we get to those asymptotes. Correct? If we look at some of our previous graphs, let me put this one up there real quick. We've done before. Okay, this is the last one we did. When x is really, really, really big, if we keep going out here forever, we get out to 1,000,000, right? And we're trying to get to our asymptote, our horizontal asymptote, or really small. You guys with me? Okay, so if I say x is a really, really, really big number, for instance, give me a really big number. How about an easy one like 1,000,000? Okay, 1,000,000. Let's go with 1,000,000. Okay, now when I say 1,000,000, if I say x is 1,000,000, or let's say I have $1,000,000. Now some of you might be a little more frugal than others, but if I say, hey, I've got $1,000,000, and your parents gives you $5 allowance that week, you're like, well, thanks, you know, I got $1,000,000, so I'm good. Or if your buddy comes up and says, hey, you've got 1,000,000 squared, which, by the way, that's 1 trillion. a million is a trillion, then we start talking about national debt now when you talk about 16 trillion, but we won't go there. Okay, but when we got 1 million squared and your buddy says, hey, can I borrow a buck? You're like, of course. I mean, the Bank of McCoy is open, you know? You give a buck, okay? So let's ignore this chump change on the side, all right? We don't even care about it for right now, right? Because in terms of a really big number, 5 of is equivalent, or is not even, it's irrelevant, thank you. And 1 is irrelevant. So let's just ignore those. Let's just say we have negative x over x squared, all right? And we're trying to figure out what we're getting really close to, right? That's our asymptote. Okay, so if I put in a million and I say I have negative 1 million, 6 zeros, right? I've substituted that in for x. And I have over x squared, which is 1 trillion, right? So maybe I shouldn't have picked such a big number. That's a lot of zeros, man. Okay, there we go. 1 trillion. Okay?
That's more money.
Now, when I cancel that, I am now left with negative 1 over 1 million. What is that really close to? It's really close to 0. So my y asymptote is 0. Aaliyah, you were correct. Well done. Y equals 0. Now I want to point out what we did here. This remember, was negative x over x squared. What if it was positive x? Would it be the same? Yeah, it's just, it would be, yeah, it's on the other side. Good. So if notice your power is bigger on the bottom than on the top. When your power is bigger on the bottom than it is on the top, your horizontal asymptote is going to be at y equals 0, unless you're adding a value to the k. So from the fractional piece, you're getting 0. If we're adding, like if we said plus 7 out here, then it would be at 7, because this is 0, and this we're adding 7. Right? If it was plus 20 out here, it would be 0 plus 20, and that would be 20 then. Our asymptote would be at 20. But if you're not adding anything to the k, any k value out there, the fractional piece, its contribution towards your asymptote is going to be nothing if the power is bigger on bottom. Doesn't matter how much bigger. If it's bigger on the bottom, your contribution from the fraction is going to be 0. Now it's going to change when the power is bigger on top, and we'll get to that here in a minute. Okay? So let's go back to our problem now. All right, let's start building our table. This is at y equals 0. Okay, so we could actually sketch in that asymptote now. All right. And we got to start building our table. Now I want 3 points on both sides of the asymptote. That's why I have so many lines here. So 1, 2, 3 asymptote. This is negative 1. 1, 2, 3 asymptote. This is 1. 1, 2, 3. Right? Our x asymptotes go there. So that's our vertical asymptote. Vertical asymptote. What's going to be up here? Negative 10. What do we end with always? 10. Okay. We good on that?
Bless you, bless you.
Whoa.
Bless you to the second. That was crazy.
Bless
Oh. All right. Hey, what's going to go in between negative 1 and 1? 0. Right? Halfway in between. Well, what goes in between there? Yeah, if we want to keep it equal, we could put any number, but 1/2 and negative 1/2 are good ones to try. Let's pick some values on here. Let's go with like negative 3, okay, and negative 6, okay. 3 and 6, okay, just because we're cool like that. All right, so now you have the option. Is it going to matter which equation you put these values into? Did we cancel anything out? No, so it doesn't matter. And it wouldn't matter, either way it wouldn't matter, I guess. But which one looks easier? The 5 minus x over x squared minus 1 or the 5 minus x over the quantity x plus 1 times x minus 1. How many say the first? How many say the second? How many say you have no choice? You don't care. You should care. Okay? So 5 minus x. Let's use the first one. I think that one looks easier. It's a more compact version. Okay? Plug all those values in and fill out that table. Ready to go. Negative 10. What's our value? 0.15. You have a second? Is that correct? Hey, how about negative 6? 0.31. Okay, how about negative 3? How about negative 1? Undefined, yeah, that's our vertical asymptote. How about negative 1/2? Negative 7.3. How about 0? Negative 5. That's called our what? Y-intercept. Label those important points. How about 1/2? Negative 6. How about 1? How about 3? How about 6?
Negative 1/35. Negative 0.2.
Okay, how about 10?
Negative 0.05 repeating.
0.3 what?
No, 0.5 repeating.
Pretty close.
So 0.55.
0.05, and the 0.5 is being repeated.
Okay, one person, please. Yes.
Negative 0.05, and the 0.5 is being repeated.
Okay, so 0.06 if we're going to the nearest hundredth. And this one to the nearest hundredth was? Yeah?
It was 0.03.
0.03. Okay, now the reality is we don't need to go to the hundredth on here, and we didn't do it here because our graph isn't that accurate on it. Okay? Let's go through here. We have negative 10, and we're at 1/15, so we're here. Negative 6, and so we're really, really close to that asymptote. And then we get to negative 3, and that's at negative 1. And then all of a sudden we jump to negative 1, we got our asymptote, and then we go to negative 1/2, which is negative 7.3, which is right there. And we have 0, negative 5, and, thank you, and we have 1/2, negative 6. We have our 1 in our asymptote. We have 3 and a 0.25. We have 6 and negative. How's that work?
You're supposed to tell us, shouldn't you?
Yeah, that's crazy, right? Look, we jumped over the asymptote there. Is that okay? Now, not like that much. Now, you guys remember me saying there's a chance that you will jump over those horizontal asymptotes. Total way. Okay? And, hey, we're going to get into that a little more tomorrow on why we can jump over those. Okay? But remember, the horizontal asymptote you can jump over a bit. Right? The vertical ones you'll never go over. Okay? So we end up with that graph, right? Well, that's not focusing too well. Okay? That graph right there. Start on 14. Like I said, we're not going to go all the way through it. I want to take that equation, the x squared minus 2 over x plus 2. You're not going to be able to cancel anything here, right? You guys with me? Okay, and so our asymptote for x is going to be negative 2, our whole, none. And the y asymptote, well, let's focus on this part again. This time we have the x squared on top. We can't reduce that because you have the minus 2 and plus 2. Okay, so if you think back to our notes we had, this time it's y equals x squared over x. We're not doing a trillion over a million because now we have to figure out how many of these go into that. And in this case, it would be, well, that's, that. Okay? We have to use this thing called polynomial long division. Oh yeah, I know, it's exciting. So we're going to put that minus 2 in and that plus 2 back in. If the power is bigger on top, use polynomial long division to find the slant asymptote or the oblique asymptote.